Reed here. What's going on, y'all? How you guys doing today? I'm gonna give it a few minutes before I start and give an opportunity for a few people to come on in. Today we're going to have a very interesting topic. It's on the frontal lobe, and the frontal lobe is the seat of your executive function. This is what makes you human, right? This is what makes you the executive, right? And loss of this is a term called executive dysfunction, meaning doesn't seem to be any purposeful behavior. It's just a lot of doing a lot of things, but nothing really meaningful and nothing really purposeful. You know? That's what executive dysfunction is. So let me go ahead and look here. First, let me see if I can go to here. Okay, let me see if I can go to Grok. Ron, how's it going, buddy? My man, Ron, how you doing? Can you hear me, Ron? How's it going, buddy? Okay, so here, first let me show you a image of the frontal lobe. Here it is. Here's the frontal lobe here in red here. And this prefrontal cortex is still a part of this frontal lobe. You know, here is the temporal lobe here, right? Here's the parietal lobe here. So what we're looking at here, we want to look at the frontal lobe here. Okay? And so let me just here briefly. What does the frontal lobe do? Here. The frontal lobe of the brain is vital to human consciousness, as well as functions that appear uniquely human, such as spoken language. Frontal lobe damage can lead to a wide variety of symptoms: memory, judgment, abstract thought, creativity, social appropriateness, motor tasks. The frontal lobes are the most common injury that occur in the brain. Damage can lead to a wide variety of symptoms such as movement difficulties, difficulty speaking, and changes in social behavior. So here's the frontal lobe here. And one of the reasons why it's important to sort of understand this part of the brain is that when you start to see individuals with behavioral problems, like problems with judgment or things like that, problems with insight, problems with organization, you want to think about the frontal lobe. And in cases with frontal lobe hypoactivity, that's usually seen in cases of attention deficit disorder, right? And remember, we place those patients on a stimulant, right? So if they're hyperactive and restless and can't sit down because attention deficit hyperactivity disorder, then why do you put them on a stimulant? Well, you want to stimulate this frontal lobe here. So the stimulant is not for the body, it's to stimulate the frontal lobe. The frontal lobe becomes more active, more dominant, and then the frontal lobe begin to suppress all the activity that you see, the excessive motor activity and things like that you see in patients with attention deficit hyperactivity disorder. So you can see how important this frontal lobe is and how important it is to know what the function is. So here, so So explain the function of the frontal lobe. So in this series, remember we looked at the hippocampus and we sort of looked at how those systems were functioning in there. Then we went to the amygdala. I remember that we did the basal ganglia. And remember, in each one of these systems, we want to look at the networking and look at the receptor profiles in here. And hopefully, if we understood the receptors, then we sort of have an idea of what type of medications we want to sort of address issues connected with dysfunction in the frontal lobe. Okay. So here, the frontal lobe, located in the front of the brain, is a critical region responsible for a wide range of higher order cognitive, and behavioral functions. It plays a central role in what makes us uniquely human, including decision making, planning, and personality expression. Below is a concise explanation of its primary functions with deeper reasoning where relevant. Okay, so look at this. So executive function and decision making, right? Motor control, remember ADHD, speech and language production, hyperactivity, that talky, personality and social behavior, attention and working memory, emotional regulation, so all of these are very important roles of the frontal lobe. So here, executive function and decision making. The frontal lobe, particularly the prefrontal cortex, is responsible for executive functions, which include problem solving, right? Reasoning, right? Planning, right? Decision making. It evaluates options, weighs consequences, and help prioritize actions based upon goals. As you can see, that's a very important function to have. Very important function: problem solving, reasoning, planning, decision making. Okay, here, motor control. The primary motor cortex, located in the posterior part of the frontal lobes, along the precentral gyrus, controls voluntary muscle movement. It sends signals to muscles throughout the body to execute precise actions when writing or while walking. So we have the primary motor cortex that's located in the frontal lobe. Controls voluntary muscle movements, So I'm sure you get the stimulants make the frontal lobe more active, so you get more control over the movements. And I guess that's the mechanism of shutting down the hyperactivity seen in attention deficit disorder. Okay, the motor cortex is organized somatotypically. That is the motor homunculus. Remember the homunculus, where specific areas correspond to specific body parts, ensuring coordinated and intentional movements. And so, here, this frontal lobe, executive functioning and motor control. Okay, speech and language. Yep, Broca's areas. Yeah, typically, it's been a while since I've pronounced Broca's areas. I even thought about this. Broca's areas, typically located in the left frontal lobe, is crucial for speech production and language production. It coordinates the muscles involved in speaking and helps form coherent sentences. It helps coordinate the muscles involved in speaking and helps form coherent sentences. Broca's area. Remember, Broca's aphasia. When we have, Broca's area, Broca's aphasia. Okay, yeah, damage to this area can result in Broca's aphasia, where individuals struggle to produce fluent speech, but still may understand language. So they can receive the information, but they simply have difficulty with the process of speaking due to the damage. Okay, personality and social behavior. The frontal lobe, especially the orbital frontal cortex, regulates personality traits, emotional responses, and social behaviors. It helps us interpret social cues, inhibit inappropriate actions, and exhibit empathy. For instance, it prevents impulsive or socially unacceptable behaviors like shouting in a quiet setting by assessing context and consequences. That makes sense. Okay. Attention and working memory. Yeah, for attention deficit disorder, right? The frontal lobe helps maintain focus and damage working memory and manage. The frontal lobe helps maintain focus and manage working memory, the ability to hold and manipulate information temporarily. Yeah. It filters distractions and sustain attentions on task, which is why frontal lobe dysfunction is also linked to conditions such as ADHD. Yeah, like we said before. Uh, Attention and working memory. This is significant. Yeah, because I thought part of the working memory was also in the prefrontal cortex also. So I can see the attention and working memory, social behaviors, Broca's aphasia, motor control, ADHD, and of course, executive dysfunction. Um, so here, emotional regulation. The prefrontal cortex interacts with the limbic system. I can imagine, yeah, to modulate emotions. To modulate emotion. It helps balance emotional impulses with rational thoughts, enabling us to stay calm under stress or delay gratification. For example, choosing to study instead of watching TV involves the frontal lobe suppressing immediate desires for a long-term goal. Yeah, yeah. For example, choosing to study instead of watching TV involves the frontal lobe suppressing immediate desires for long-term goals. Huh, amazing. The frontal lobe is one of the last brain regions to fully mature. Yeah. Not often until the mid 20s, which explains why adolescents may struggle with impulse control or long term planning. Yeah. Why they need so much support and structure. Damage to the frontal lobes via trauma, strokes, or neurodegenerative diseases can lead to impairment in poor decision making, apathy, or disinhibition, depending on the affected subregions. Yeah, we see that a lot in diffuse traumatic brain injuries and things like that, damage to the frontal lobe. You see the impulsivity, the agitation, combativeness, aggressiveness, the unpredictable nature of it all. Um, yeah, its connectivity with other brain regions like the limbic system and the parietal lobe allows it to integrate sensory, emotional, and cognitive information for cohesive behavioral experience. And so this is this is really interesting on the frontal lobe here. Um, so also, let me see if it can explain the networks going through the frontal lobe. Can explain the operating frontal lobe. The frontal parietal network. The default node network, the salence network. Yep. I'm not sure if this is going to be what you guys are interested in as medical students, things like that. Oh, it's giving all the networks. Okay, here, the frontal lobe is integral to multiple neural networks, each specialized for distinct functions. The FPN for cognitive control, the DNV for self-reflection, the SN for salience detections, CON for sustained attention, the frontal striatal for reward and habit, motor network for movement, and language network for speech. I wanted to point out that they did go through the process of sort of labeling these huge networks that sort of helped these lobes function like this. So let me just go through a few of them just to show you, but not too much. This frontal parietal network. It is critical for high levels of cognitive functioning, including working memory, problem solving, planning, and cognitive control. Okay, look at this. Oh, how it works. The FPN integrates information from sensory and memory systems to guide goal-directed behavior. Okay, and the default mode network. It is the DMV is involved in internally focused process such as self-reflection, mind wandering, autobiographical memory, and image future scenarios. And so I just wanted to choose that. Didn't want to get too deep into it, but also let me go through and see if they can describe the receptor profiles. The receptor profiles in the frontal lobe. And remember, we covered the amygdala yesterday. And remember, we're looking at the different receptors. I'm sure it's the same group of receptors: glutamate, GABA, dopamine, right? Serotonin, norepinephrine. The frontal lobe, a critical region for cognitive, emotional, and motor, right? So cognitive, emotional, motor functions contain a diverse array of neurotransmitter receptors that mediate neuronal communications and modulate network activity. These receptor profiles determine how neurons in the frontal lobe respond to neurotransmitters, right? Drugs and other signaling molecules influencing the function. Right. So we want to look at the receptors. And so at least if you understand the receptors in this region, at least you understand what medications you can reach for. Remember, so we have our glutamate receptors. You know, we have one of the medications I use to target glutamate is Namenda. And so it decreases glutaminergic activity. That's very helpful in patients I use with agitation. We have GABA receptors, typically benzodiazepines, right? We can use to sort of help with any agitation or combativeness there. And remember, for glutamate and GABA, these are the main. Glutamate is the main excitatory neurotransmitter. GABA is the main inhibitory neurotransmitter. And you want to get balance between both. Remember, the major the major mood stabilizers like Depakote and lithium results in down regulation of glutamate receptors and upregulation of GABA receptor. So remember, with chronic agitation, combativeness, maybe head injuries, with impulsivities, restlessness, and things like that, you really want to make sure that you can use your mood stabilizers to target both the glutamate here and the GABA receptors all in one here. So I think this is one of the reasons why Depakote and lithium are very effective in diffuse traumatic brain injuries, particularly ones that may involve the frontal lobe. So here are glutamate receptors, GABA receptors. So GABA, the major mood stabilizers, and also benzodiazepines, IM benzodiazepines. Okay, now dopamine receptors. Okay, so it has D1 receptors, right? And then it has also D2 receptors, D2-like receptors. Remember, for the typical antipsychotics, they primarily bind D2 receptors, not necessarily D1 receptors. They have a very high affinity for these receptors, so they bind them very strongly. That's the typical antipsychotics. Now, remember, the atypical antipsychotics also, they bind D1 receptors, D2 receptors, and also serotonin receptors, norepinephrine receptors, either acetylcholine receptors too. So in this case, a mood stabilizer can help downregulate glutamate receptors, upregulate GABA receptors. And if it's an urgency, you can use benzodiazepines urgently to target GABA to activate those receptors to get the inhibitory benefits. With a typical antipsychotic, you'll target the D2 receptor here, but you won't target any of the other receptors. If you were to use a atypical antipsychotics, it'll target D1 receptors, D2 receptors, the serotonergic receptors. Some of them target the acetylcholine receptors. So that's why mood stabilizers like Depakote lithium and atypical antipsychotics like Seroquel, Risperdal, Geodon are very helpful in things like diffuse traumatic brain injuries. Does that make sense, guys? Hope so. Let me see here. Let me see if I can get any questions here. I'm here at 20 minutes, and so I didn't want to go too far over 20 minutes. I didn't want these little sessions to be too long, but let me see if I can answer one question. Hey, Mohammed, how's it going, buddy? Thanks for the question, Mohammed. Is the frontal lobe the true seat of free will? I would say absolutely. That's where you decide to turn left or to turn right, and that's the ultimate decisions. Okay. All right, guys, I think that's it for today. I hope that was helpful for you guys. If you have any questions, you can just put them in the comment section. And so this is on the frontal lobe. I hope it's helpful for you guys. Take care, guys.